So again, I want to welcome you all to IndyAWS. This is the November 2017 edition. Today we're going to be talking about using SaltStack and the AWS SaltStack Formulas for creating some VPCs. It's a really nice demo of how you can use some of the orchestration capabilities and the configuration management capabilities of SaltStack to configure AWS resources. So I thought this would be pretty relevant. My name is Hendryx-Parker. I'm 6 Feet Up CTO and co-founder. I'm also the co-organizer of this meetup and the IndyPie meetup. So you can easily find me online. At the very end, I've got my Twitter handle. So not only can you follow IndyAWS, but you can come follow me, CalvinHP. So I'm certain the first question you're probably asking is, what the heck is Salt? Who in the room is actually using Salt already? All right, so this is going to be perfect, because it's a nice intro talk. This is not a very advanced talk. I'm going to cover some of the core concepts around Salt, and then I'm going to show off a quick demo of how we can actually leverage those things to produce a network inside of the AWS cloud. So Salt itself is event-driven data center orchestration. It is more than just configuration management. Who else in the room is using configuration management of some kind? Whether it's like Puppet, Chef, CF Engine, just one hand? How do you guys repeat your servers in a reliable fashion? Okay, cool. So what Salt does over, oh, by the way, these are the two Salt founders right here. Tom Hatch in the front and Mark Chen in the back. They founded SaltStack. This year's theme at the SaltConf was outer space, sci-fi, and they did a whole beautiful video thing that you can actually find online, which is really funny. So what sets Salt apart from other configuration management tools? I mean, in general, configuration management tools help us build out consistent images or consistent servers or consistent virtual machines, or can control pieces on our network to make sure that they've got the correct settings and can ensure that they don't stray from a known good set of settings. That's what most configuration management tools do, but Salt does a lot more in addition to just straight up configuration management. The original reason why I chose Salt for our infrastructure was actually remote execution. You can drive Salt and actually query your whole infrastructure as if it's a big giant database. You can ask it for information about what interfaces it sees and what kind of machines it's got, what OSs are on there, what versions of software are running. Any kind of metadata you want to gather off your running infrastructure, it can do it in real time across 10 machines, 100 machines, or 1,000 machines. It actually, I'll show in an architecture diagram later that we use 0MQ to do all this work in parallel, so we can very quickly query thousands of machines simultaneously asking for information. The second thing it does differently is event-driven orchestration. So since we're at an AWS meetup, if you guys are familiar with CloudTrail, how it sends out and emits events inside of the AWS infrastructure, you can think about that the same way as Salt does for controlling all of your Salt minions and actually more infrastructure and hardware, is that we can actually listen for various events happening on that 0MQ bus. When things happen on the bus, for example, new what are called minions spinning up, which are like the little servers, they're all called minions. There's masters and minions. When those minions spin up and add themselves to the master, there'll be events when you can set up beacons to actually emit events when people log into servers or to watch files. So if you want to monitor a file and make sure that no changes happen to that file, or when changes do happen to the file, you can then react to it. Event-driven orchestration lets you do all of that. Also with event-driven orchestration, this is what we use it for. We replace some other tools like Fabric. If you guys ever use Fabric for deployment or Capistrano for deployment, you can do the similar activities with SaltStack out of the box by doing code releases, for example. The benefit of orchestration over just plain old configuration management is I can actually control dependencies across multiple machines and different layers of the infrastructure. So I can actually have dependencies between machines that the app servers can't come up unless there's database servers alive. And the load balancer can't include those app servers unless they actually are checked in and alive as well. And when I do code releases, I can say release code, but do it on a rolling basis and control which app servers are actually in the load balancer in real time as I release my code across the infrastructure, so I can do a zero downtime release. Some other technologies like Ansible do an agentless operation. Salt can function in either mode where you run an agent on your VMs or minions, or you run without an agent at all, an agent mechanism where, for example, we can use SSH as a transport instead of running an agent on your minions. Or you can actually run without a master altogether and just check the state files, which I'll show you in a minute, directly out to the machine and run them as on the local machine directly. So you don't actually even require to set up a master server at all to play with Salt, which is nice. During the demo, I'll be using it masterless. So we'll have all the state files. It'll be a full running Salt setup, but there'll be no master and minion involved. There's just going to be the minion. Salt has tools for doing cloud provisioning. So if you're familiar with tools like Terraform, you can now incorporate that piece of your infrastructure management into Salt directly, so it can spin up VMs, shut down VMs, manage the infrastructure in multiple cloud providers simultaneously. So if you want to do across AWS, Azure, DigitalOcean, there's a bunch of providers that are all supported. And then I find that Salt has a speed and scalability in its court. If anyone's done Puppet or Chef across a large infrastructure or Ansible across a large number of nodes, the comparable speed of Salt is going to be a much faster experience on the Salt stack versus some of those solutions. And a lot of that comes down to their choice of technologies underneath the hood, which is like the event bus in 0MQ. So when we talked a little bit about some of the Salt architecture, let me give you a quick little rundown here. We talked about masters and minions. So on the top of the slide here, we've got the master. And the master can run many different operations directly. So for example, you may talk to cloud providers and spin up infrastructure. It hosts a file server where you can actually store configuration files that would be deployed into your minions down below. You can actually do authentication into the master, so you can have full access controls on who can run which Salt commands where, which is nice. There is Salt Pillar and Salt Mine. Those two technologies are there for storing data, providing data to the minions on an as-needed basis. The Salt Mine allows minions, for example, to save data to the master for another minion to grab later. So in the case of like a load balancer, you may want to have the application servers register themselves and put data into that mine that then the load balancer will read when it sees that and can now rewrite its configuration based on all the data available in that Salt mine. These things all sit on top of the event bus, which is 0MQ, and the runner can then do operations across the infrastructure, across machines versus just inside of a single machine. Reactors can listen for events on the bus and react appropriately. So for example, if a minion disappears, we can actually spin up a fresh VM, install and high state it to a correct state and add it back in the load balancer. Salt engines maintain persistent connections. So this is a case where you may have like a chat ops going and you want to have Slack hooked up constantly, or Logstash or SQS. And so that maintains a persistent connection into third-party services where you can then do additional integrations. And then we have a full like a REST API that supports WebSockets and straight-up REST operations. So you can actually listen to the event bus in real time over WebSockets with Salt. Then down below, we have our minions. So on the minions themselves, they can do most of the things that a Salt master can do. So that's why we can run without a master altogether. But we have returners, grains, and beacons. So beacons send out events to the bus that we can then react to. The returners can send data into like Kibana or Logstash or into a database, so you can actually have an audit trail of actions that happen on all the minions across your whole infrastructure. And then the grains are metadata that you can assign on either metadata that exists on a server or metadata that you can specifically assign into machines. So you could think of that as what CPUs are in the box, what interfaces are on the box, what disks are in the box, or this box has a role of application server, this box has a role of database server, this is the dev environment, this is the staging environment, this is the production environment, and that's all metadata you can then use when orchestrating inside your environment. So if anyone's doing continuous deployment, you could then use that Salt stack as a piece in your continuous deployment pipeline to actually handle the orchestration of the releases. So if you're using Jenkins to do CI, and then once it passes, there may be some other checks, it can then move on and actually spawn orchestration tasks to happen here inside of Salt. Any questions about the Salt internals? There's a lot there. It's a very big project. Luckily, it's very easy to get started with, which I'll show during the demo. So there's a little more in detail of like inside of a Salt minion and master what are happening at each spot. I won't go in too much detail on this because I do want to get to the actual demonstration of like the technology. But this is a good kind of overview showing the event master bus, which is a little cloud up there that it will spawn. Each of these boxes are technically processes that run on your machines. So in your master, you'll have n number of workers, which is the little gear up in the corner, and then you'll have the local client, which will act just like any other minion, plus the request servers and publishers, which then talk and receive information from the various minions over the 0MQ bus. So each of these would represent processes running. Unless you did an agentless, well, then the minion would not have the Salt processes running, but you would use like SSH transport, or you would call Salt manually on those machines. Enough talk, let's actually create some stuff, because that's why we're here. So what we're going to do in this case, for this demonstration, is I'm going to set up an AWS VPC and add in a public and a private subnet and set up a NAT gateway and an internet gateway, all from one command and one set of states. Has anyone ever done this set of tasks before? You can be kind of tedious. Did you do it through the wizard online? With what? Terraform. Okay, so you already know the wonders of orchestrating cloud infrastructure. Doing this through the actual UI can be, like I said, tedious at best. Let me show you real quick. Here we go. So if this is the Amazon Web Services. We're logged in. You can create a VPC, and then all of a sudden you're presented with form upon form upon form of things to do. So if I do prod VPC, and you have to give it a block of addresses, and say yes, create. /24. Now what this leaves us with is just the VPC, but without any subnets. We now have to manually go through and click through subnets, internet gateways, NAT gateways, and configure all the pieces ourselves. But that means you have to leave this screen, go to 5 other screens to do these things, and all the while you're like, well, which blocks did I use, and how do I want to like lay this all out? This is where I find it to be a little difficult to use the GUI to do these kinds of operations, because you have to kind of track a lot of information simultaneously to get this actually to be successful. All right, so that's the manual way of doing this fun operation. So, and that's kind of what I mentioned here. We're basically building up subnets, public and private. More than just NAT and internet gateways, there's also peering, all the route tables. I mean, if you have to be a network engineer in Amazon's world to be able to do these things from scratch. I think that's why they give you a default VPC out of the box that most people, probably 99% of the people use the default VPC because it's all set up and ready to go. But that doesn't give you the benefit of things like the private subnets where you may want to put services completely behind the firewall that aren't accessible from the internet at large. So to do this, we're actually going to set up SaltStack with what are called formulas. And formulas are reusable, testable, and configurable. They're basically self-contained chunks of Salt configuration state that you can share with others or reuse across other projects. Some examples of this are, for example, we use Varnish in our infrastructure. We'll have HA proxy in our infrastructure. I'll have a Redis formula. So I'll set up a formula for each of these software packages, and then that formula knows how to deploy that cross-platform. So I may be deploying to Ubuntu, CentOS, FreeBSD, OpenBSD. I can actually write one set of states that work across all those platforms. So I don't care what my target environment is. I just include this formula in my states and say go, and it makes all the decisions and knows how to map the right package names to the correct platforms, knows where to expect all the configuration files to be. So the example I'm going to be using today is actually up on GitHub. The address is here, if it stays on the screen, in the SaltStack Formulas organization. It's not I don't know if it's official organization from SaltStack, but there's a whole set of these formulas up there for you ready to use. So if you're doing MySQL, Postgres, Nginx, Apache, there are formulas already up there for you to use. And the one that I have selected is the AWS formula because it actually makes it really easy to build out this infrastructure. It has a set of salt states that leverage Salt's built-in ability to talk to the AWS and to create all this network infrastructure. But if you were to write that out by hand, even in Salt, it would still be tedious. Someone has gone through and scripted all the tediousness inside of Salt for you, and then allowed you to use Pillar, which I talked about Pillar earlier on in the architecture. Pillar is a data store of content for you. So when we talk about Salt pillars, we'll talk about pillars and we'll talk about states. So the Salt states are the templates that would describe the thing you want to build. So if I was doing an Nginx formula, I would have a template of Salt state that would say install the Nginx package. But in there I would probably parameterize what the name of the Nginx package is, because on different platforms it may be called different things. The pillar will fill in that blank with, oh, for this specific machine you need this specific package of Nginx or this specific version of Nginx used there. So you can think of like pillars as the data, and when I say the word states, those are going to be the templates that we're going to fill when we actually apply this state onto a machine. So another nice thing about Pillar allows us also to securely distribute secrets to our machines. Now, storing the secrets is something separate from what Salt does, but you can use technologies like Vault, or there's other keychain type technologies. But there is a Pillar front end for Vault, for example, that can target a specific machine. So I say the production app servers only get this database password, the staging app servers only get this database password, and the staging machines can't attempt to request the production password from the Salt master, where the production ones can. So it's host specific. This is an example of a pillar. It is YAML, so that's what this markup is right here. It's basically a white space formatted text file, and it is dictionaries and lists. Actually, in this case, it's only dictionaries. YAMLs, this is the data structure for a dictionary. Each of the lines, each of the words before a colon is a key, and each of the things after the colon is a value. So in this case, we have a key AWS that contains a dictionary that has a key region that contains a dictionary that contains the region, the actual region we want to deploy into. So this is actually the data I'm going to be running today against the AWS infrastructure to create out a subnet down here at the very bottom. It'll create a public subnet in AZ2, and it'll hook up a NAT gateway for us automatically. The rest of this is just selecting what IP block we want to contain. You can set up the name of your VPC, so that's the tag that your VPC will get inside of the infrastructure. And then there's other options in here, whether you have an internet gateway created or not. And if I wanted to create other subnets in here, I would just include more keys. So there's a .1, .2, .3, .4. I could create 5 subnets just by adding in those bottom 4 lines, copying those, pasting them again, and now I've created subnets that would match. So in this case, the CIDR prefix, the CIDR prefix is 172.20. It'll create a .1 network. So 172.20.1 will be the first network it creates with this pillar information I'm getting ready to pass it. You may notice that the profile up there for our AWS has the key ID and key installed into it. You would typically not want to store that information inside your pillar file. You would probably actually have that inside of like something like Vault. In my case for this demo, I did not include the key ID and key in my pillar information, but I put it in the minion's configuration file. So you can store it in the configuration file of the minion itself, and then when it runs, it will pick up that as additional metadata that it can use. So you can protect that file. You could run it in Vault, use environment variables. There's a lot of different options, but don't put your key IDs and keys inside of your pillar files if you can avoid it. Use some mechanism to actually protect it. Just putting it out there.
And then don't put it in GitHub.
Yeah, don't put it in GitHub, and that way you won't incur a $65,000 bill for random people spinning up EC2 instances on your dime. Did you guys all hear this story? Like, 2 days ago, right? They released it. Some UK consulting company is like, oh, this is too hard. I'm just going to put this up in GitHub so I can work on it, and they end up having their AWS credentials built into that repository. It's genius. So then once we have our pillar set up, and before we want to actually run this against our infrastructure, we need to be able to target this pillar. Because remember I said pillars are host specific. So I want to make sure that only specific machines have access to this data and not others. But for the use of this demo, what I'm going to do is I'm going to target it to star. So you can actually have multiple environments inside of Salt. The default one is just called base. This is a top.sls pillar. And what the top files do inside of Salt is help you target your states and pillars to specific machines in your environment, or even specific hardware. The possibilities are limitless. Salt actually enables you to control networking hardware, devices that were never supposed to be controlled by, configuration management type tools. But in this case, I'm telling the glob, I'm using the glob star to say any machine can run this state and grab that data that's in the AWS SLS file. So this previous file here will be named aws.sls, and then it will be available in pillar data to any machine. You can actually do globs here, like based on host name. You can do regexes against host names. You can also select machines based on grains. So remember I said grains can do things like say what the node type is or what environment this is. So I could be like in the dev environment, app server, glob machines all have access to this data versus the production machines having access to maybe a different set of data. You can also, there's a bunch of different ways you can target, which is one really nice thing about Salt. It's very, very flexible about how you can actually target and get machines selected to get the right data assigned to them. So again, enough talk, let's put this all together. Let me show you how this all works. Maybe. Here we go. Okay. So I've actually, I'm running my Salt state from a DigitalOcean droplet just for fun. Actually, mostly because last night I did not have my laptop at home when I was doing the demo. So I needed a machine I could shell into quickly and cheaply. So I've cloned the AWS formula down to this machine, that one I gave you the link for in the previous screen. And you'll see the structure of this. We have a pillar example. Inside that pillar directory, we have our aws.sls file and our top.sls. So if we look at that, this file here, that's the file I just showed you up on the screen. Same file, same thing for the top file. Now the magic all happens in this formula inside the AWS directory here. Inside here, there are SLS files and Jinja files. So Salt uses a combination of YAML formatted files, but it can be templated using Jinja. So if you're familiar with Jinja or ever done Django, which uses a similar templating syntax to Jinja or Flask, Jinja is just a templating language. It uses curly braces to allow you to substitute variables in. And so if we look at, for example, the VPC state here, you'll see that there are templatized areas and loops. So actually what it does is it loops through the data structure inside my pillar, picks up the AWS key, picks up the what region I'm going to be in, and then goes from there to pick up all the pieces then to start building that infrastructure. And then down here it uses the Salt states. So this second argument, this Bado VPC present, that runs the Python Bado library internally and fills in all the metadata that's been provided in the pillar for us. So it basically just looks into the VPC pillar, pulls out all the key value pairs, and then creates them as options that it feeds into the arguments of the Salt state that does the VPC present. Same thing happens for like the internet gateway, and then down here for the subnets and NAT gateways, and all the infrastructure pieces are templatized in here and read from that pillar file. If we look right now, if I do AWS EC2, so if I describe the VPCs, you'll see that there is the one I just created from hand while I was doing through the web demo there. That's called prod VPC. So that's the only VPC that exists there right now. And if we look at our pillar, what we're going to create, to go up a directory. We're going to create a VPC called demo-blog-VPC. The reason it's named that is I actually have a blog post that goes through this step by step. So if you want to try it on your own later, you can by going to the link at the very end of this presentation, and you can actually get all the files and everything you need to do this. So now to run this, to grab the plain text here. This is the structure of running a salt call command. So when we normally run salt and we're having a master and a minion, I'll use the salt command to run some what's called a module against our infrastructure. In this case, I'm running the one called state.sls. So that's the first argument to it right here. And then I'm telling it to run the AWS state. Now I'm running salt call and doing it locally so that I don't have to have a master. That's what all this is doing, is basically turning this into a masterless minion where I don't have to have the master present to do an operation. So if you have security concerns around network traffic and using the 0MQ stuff, you can nix all that and actually run like this from the command line or through your own automation system or whatever messaging system you like. I'm telling it to run local, which means don't talk to a master. The file root is going to be the current working directory, which is the formula I pulled out. And then the pillar root is the directory called pillar. So it's saying, look for pillar information in that directory where I have that top file and the AWS.SLS file. Now when I run this, it should give me a nice output, what happened, what failed and what succeeded. Hopefully the demo gods are kind and we get a success. Yes. So it succeeded, it ran and created the 4 pieces of infrastructure, which was the VPC, the NAT gateway, internet gateway, and the one public subnet. The output is currently in like a YAML style format, but through returners, you can turn that into database inserts or throw it onto a Kibana bus or whatever you'd want. Is you could actually pull that back in CSV format. So if you've got other operations that would depend on data coming from the result of this, for example, you may need to know the VPC ID for doing future operations. You can grab that information out because it does get returned to you when you run these states against the infrastructure. So there is our VPC. See, it shows you what it was and what it is now. So the old one, there was none that was named that, so it got created. Our internet gateway, same thing. You can grab the ID of that if you needed to associate that then to another subnet along the line. But if you just add another subnet, well, here, we'll do that as part of the demo. Just so you can see that I'm not lying, there's no man behind the curtain. If we refresh this, we have the prod VPC. Oh, you know what? It created it in California. There it is. That is our VPC that we just created right here. Now, if I wanted to add an additional subnet, so if we look over here, subnets, there is our blog subnet right here that it created for us. If we come back and edit the pillar, and we'll create this one. Actually, we'll do it in the A. Oops. So we're going to actually create another subnet in a different availability zone on the fly here. I'll replace that with A. And we can rerun our same set of states against the infrastructure. We should see one change where it created an additional subnet. Maybe the name has to be the same. Got A and B here. Seems to be unhappy with me. That's the theory. We'll go with that for right now. But you should be able to just add that data into the pillar. These should be safe to rerun multiple times. So for example, if I was to take this back out, oops. I'll edit this and there we go. So in each pass, it just will ensure that those things exist. So in this pass, there should be no changes made because the things all existed already inside the infrastructure. So if you modified one, then it would do the appropriate modifications to the existing infrastructure to make sure those worked. Oh, I know it wrong. Did I not name that too? Must have. Oh well, I won't debug this live for you guys. That's no fun. All right. that's the basics of how we can use SaltStack. The link here is a post I did last month on doing exactly this, so you can go try it yourself. It has step-by-step instructions. If you're on a Macintosh, you can use Homebrew to install SaltStack locally and actually run those operations I ran from the droplet directly on your Mac against the AWS infrastructure. Any questions? Yeah. Well, the master is going to be the event bus. So if you're doing things that are dependent on events happening on that bus, then yes, you want to make sure your master is alive. A common pattern is to be run with multiple masters. So you may have a master per rack or per cage or per data center, depending on what your scale is, and then have them all. You can actually coordinate multiple masters from a Uber master in a hierarchical fashion. So yeah, the minions themselves won't stop doing their work, and if the master goes down and comes back, then things will just resume where they took off, but you'll have missed those messages that came across the bus. Now, what I would recommend in those cases is you actually use something like Kibana as a returner. So if you are running operations or things are happening on your minions that you want to ensure get logged, use Kibana to throw that stuff onto the bus to ensure that they get persisted. Any other questions? Yeah, Ken.
Correlate content so I'm assuming SALT stands for something.
No, it's not. So SaltStack is an open source project. They have SaltStack, the company has an enterprise GUI that they lay on top of this. But the Salt name, I got this story from the horse's mouth literally 3 weeks ago. Tom Hatch in a Q&A got asked the exact same question. There is a scene in Lord of the Rings where they are talking about salted pork. And he's like, yeah, salted pork does sound good. And so he named it Salt. It came from that scene in the movie.
Really?
Yeah. But he liked it because salt was, stackable and the crystal structure. It seemed to represent the thing he wanted pretty well. But yeah, the inspiration for the name came from that scene. Yeah.
You said you guys are running this at 6 feet out.
Yes.
Do you have the enterprise or are you running the open?
We're running the open source version of it. What's nice about I am not a fan of open core software, and this is not open core. This is a fully open source project. They just provide value on top that does not detract from the core product itself. The enterprise customers are running the exact same version of Salt that I'm running as well. The only thing that they do on top of it is pretty much there's a really nice, it's a very nice GUI that allows non-technical folks to be able to see the result of states run, see the status of minions, view past jobs that have run, schedule jobs. It's really nice for doing a lot of the stuff I like to do from the command line.
Since you can use this to run a command across all your servers, does the open side have role-based access control, or is that only the enterprise?
So the open source Salt Master does have role-based access controls. The Salt Enterprise adds on to that support for other authenticators like LDAP or SAML or some other whatever authentication tools you want. Out of the box, it'll support just doing PAM and I can't remember what the other ones were, but PAM suffices for most people's needs if you just have user accounts in the box and you want to limit what they can do inside Salt. Because otherwise you're doing what I just did there, which is running sudo. You can actually do it without sudo access, allow actual regular user accounts to run specific states. So I ran state.sls. I can allow only Bob, Frank, and Joe to run state.sls, and then Calvin can run everything. Any other questions? Awesome.